Hello gentlemen, the purpose of this video is to again look at dividing polynomials, but this time we're going to use a different technique. We're going to use a technique called synthetic division. And hopefully you guys seen a little bit of this in Algebra 2, but we'll probably take it to a different level. Let's look at something real simple with synthetic division in terms of, let's look at a cubic polynomial with ax cubed plus bx squared plus cx plus d, and we're going to divide by a factor of x minus k. And so here's how we set it up. We take the coefficients of the dividend. Here's the dividend. So the coefficients are A, B, C, and D in this particular case. And then we need to have it in the divisor in the form of x minus k. And then we take the k term and we put it over here. Okay? And the important thing to note is if they skipped a term here, and you'll see this in one of my examples, so if it was like 5x cubed plus 6x and there was no x squared term, you need to put a 0 in there. But we'll see that in a minute. Basically what you want to do is you bring the first term down, okay, and the vertical pattern is addition. The diagonal pattern is multiplication. So I'm going to take this value, multiply it by this, and I get Ka. Then what I'll end up doing is I'm going to add down, then multiply across, and I'm going to just keep this process going until I get to the end. And this right here is called my remainder. Okay? And note that synthetic division works only when your divisors are in this form right there. Okay? So let's look at doing a couple examples. I want to use synthetic division to divide 5x cubed plus 18x squared plus 7x minus 6 by x plus 3. So one thing I want you to note is that when we have x plus 3 over here, this is x minus k is equal to x plus 3. That means that my k here is going to be negative 3. Alright, that's important to know. So I set it up. Here are my coefficients, 5, 18, 7, and negative 6. No skip terms here. And I have my negative 3. First step, bring the 5 down. Okay, whoops. Bring the 5 down. Multiply the 5 by negative 3. I get negative 15. Remember, I'm diagonal, I'm multiplying. Now I need to add 18 minus 15 is 3. Multiply by negative 3, I get negative 9. Negative 2, 6, 0. So that tells me that my remainder here is 0. And that 5x cubed plus 18x squared plus 7x minus 6 divided by x plus 3 is equal to 5x squared plus 3x minus 2. The other thing that you should note is because the remainder is 0, that this is a root of this equation, or a 0 of this equation. So x is equal to negative 3. That is going to be one of our zeros. Okay? And we need to, this is exactly what this is saying. So that factor theorem is telling me that x equals negative 3 is a 0 because my remainder is 0. It also tells me that f of, and again that's part of being a 0, f of negative 3 here is going to be equal to 0. It's the same thing. Okay? Hopefully that makes some sense. So in this example, x plus 3 is a factor of this. And I could factor this more. This is just a quadratic, and I could use a quadratic formula to get zeros here, or I could try to factor that. Let's do another example. 5x cubed plus 6x plus 8 divided by x minus x plus 2. Note here that I have a 0 right there, and that's because there's no x squared term. Okay, there's no x squared term, but I still need to put that 0 in there to be a holder. Again, this is x minus k equals x plus 2, so k has to equal negative 2, and that's why that's negative right there. Okay? So let's bring down the 5. We get negative 10. Bring down, I do addition, I get, whoops, I get negative 10, multiply, I get 20, add 26, negative 52, negative 44. So now my remainder, this one is not a perfect root, but I have a remainder of negative 44, which tells me that when I do this division here, I get this term. Okay, what I do is I take this, what I have on the bottom, and I go one power less. I start with one power less, so it's 5x squared minus 10x plus 26. Then I have my remainder term. Okay? So this term, I start with since this was x cubed, I start with x squared. 1 less than the degree that was up here originally. Okay? And remember, we're always dividing by x minus k when I'm using synthetic division. This wouldn't work if this was a 2, x squared plus 2. I can't use synthetic division. In those situations, I have to use long division. All right? So what does this remainder theorem tells me is if a polynomial is divided by x minus k, the remainder is equal to the function value. So what we just determined was that f of negative 2 is equal to negative 44. And if you try that and do it out, you will see that that is true. Okay? Now the remainder theorem is carried out a little bit further. The remainder argues the value of the function at that specific k value. So the remainder of the synthetic division is equal to f of k. If r is equal to 0, if I get 0 when I do synthetic division, then I'm a factor. And obviously if I'm a factor, the point k comma 0 is going to be an x-intercept. Okay, these you already know. All right. Let's use synthetic division to find g of 2. So again, I want to set up my synthetic division. Again, I have 2 zeros here because there's no x to the 5th term and there's no x term here. I want to find g of 2, so I put my 2 out here and just do synthetic division. 2 down, multiply, then I add, then I multiply again, 0, multiply, 3, multiply, add, 14. So my remainder is 14, and what the remainder theorem tells me is that g of 2 is going to be equal to 14. Okay? Hopefully that makes some sense. Let's do another one. Use synthetic division to show that x and negative 4 is a solution. In other words, I want to show that this is a 0. So when I do my synthetic division, I should get 0 for a remainder. So again, I set up my synthetic division. Again, there's a 0 because there's no x squared term. I want to show that x is negative 4 is the solution, so I put negative 4 out there. Bring it down, 1, negative 4, positive 16, negative 12, positive 48, 0. Remainder is now 0. So I can write that x cubed minus 28x minus 48 divided by x plus 4 is equal to x squared minus 4x minus 12. Remember, I'm starting with a power less, 1 less than the degree that was in the dividend. Okay? I can then write that like this. I can factor this term. It's just a quadratic. I can factor that. And that's going to tell me I have zeros at x equals negative 4, x equals 6, and x equals negative 2. So I can tell those are my zeros right there. Okay, so that's how I can use synthetic division to show that. Here's some reading. I'll read a few pages. Check these examples out, fellas. Here's some problems that I'm going to practice with synthetic division. So basically, we looked at synthetic division, and we had to use factors of x minus k, okay? And then it allowed us to find either a function value at a specific point, or it helped us factor something so that I could find zeros, okay? Hopefully that makes sense. Any questions, make sure you email me. Thanks, fellas. Have a good day.